Hello, welcome to this lesson. Now we're going to work on an assignment, and it has to do with this stock analysis project that you worked on several lessons ago when we were talking about files. You created this file reader class in the file processors package, so make sure that you already have that code in place before starting this assignment. If not, that's okay. You can download the code for this lecture, and that code will already be populated in this stock file reader class. If you open it up, this method here should already be completed. So in this lesson, you're going to be reading code that has already been written, and you're going to integrate that code with new code that you'll write. Okay, this is a very practical assignment. You have to do this sort of thing in the practical workplace all the time. Use other people's code in your own code. And that's in this aggregators package, okay? I've already, for the most part, completed most of the code in aggregator.java as well as this max, mean, and min aggregator classes. And I'll go over in just a second what these classes do. And then in the client package, this is the class that's going to contain the main method. So let's expand that. When you right-click for this assignment, you run as Java application, and it should behave as I'll show you in just a second, okay? So the deliverable for this assignment is for you to be able to run this code in this aggregator app class and make sure that it solves the given problem. So what is the problem? This file, table.csv, you should already know what this file is. Not important to go over the columns. This is the same file that you worked with in the processing files project. But basically, we have 6 columns here of random data. And if I wanted to calculate the minimum number in the first column or the second column or the third column, how would I do that? Well, in Excel, it's pretty straightforward. You don't need to know Excel for this, but I'm just going to prove to you that we can just do a min and then highlight all of these numbers. And that gives us the minimum value. So the number 90 is the smallest value in this column. And if I wanted to do that for all of these columns, I could just drag that and it gives us the different values. As well as, instead of min, I could use max. Okay, and this gives me the maximum number that's in the data of this column, okay? But how would I do this programmatically in Java? That's the assignment. So I've created these aggregator classes. There's one called max aggregator that gives a maximum number in a given series of numbers, and the minimum aggregator gives a minimum number in a series of numbers, and the mean aggregator is supposed to give the average. That's what mean, M-E-A-N, mean means. It gives you the average number. So if you have 1, 2, 3, 4, 5, if that's what you feed to this mean aggregator, it's supposed to give us 2.5. So for this assignment, I'd like you to go through the aggregator class, the max, the min, and the mean aggregator to figure out what's going on first. After that, you're supposed to complete this aggregator processor.java. I'm not going to show you here because I've already completed the code, but when you download this code for this project, you're going to have almost an empty class for aggregator processor. So the idea is that I can have a max aggregator. I pass that into this generic class called aggregator processor, right? So you're going to be creating a generic class called aggregator processor, and you can pass in this max aggregator as well as this file called table.csv, as well as this instance, which I call agg. That's just this max aggregator. And because this is a max aggregator, this is going to give me the maximum number in the first column, of the file table.csv. Okay, so with the way this is currently set up, this is going to give me the maximum number of the data in the first column here. So instead of min, let me change this to max, and let's hit run, and 144.2289. When I run this code, that's the number that I'd like to be displayed here. That's what this value field is going to contain. It's going to contain this number called 144.2899. So let's hit play, and notice that's the exact number that is printed out. So your job is to complete this run aggregator method inside of this aggregator processor class. So this project involves various aspects of understanding how to involve multiple classes to solve a given problem. You should already have the ability to read data from files. You've completed that in the file processing chapter. But the real meat for this project is this aggregator processor class that you will be completing. And this run aggregator method that you'll be implementing in this class is going to take the argument for the particular column. So 1 represents the first column of that Excel file, 2 represents the second column, 3, and so on. So in this example, we're passing in a 1 to represent the first column that we want to aggregate over. And this is going to be a generic class. So over here, we're using a max aggregator. So if I change this to min aggregator, right, let's just copy paste that here, do the Control-Shift-O to bring in the import. We brought in the min aggregator class, which, you'll already have this class. Okay, I've already written this code out for you for the different aggregators. The only code that you don't have is this aggregator processor class that you're going to be creating your own. But anyway, I've created this min aggregator. So this ag variable is now no longer an instance of max aggregator. That's why this is complaining. So let's change this to min aggregator, right? Inside the generics, it's now min aggregator, and now it should be compiling fine. So because of that, because we're using a min aggregator and we're running this run aggregator on the first column, instead of 144, it should return the minimum. So let's change this back to min. It should return 90, okay? Because that 90 is the smallest number in the first column. And I'm stating that I want to calculate the minimum of the first column. So let's hit run and notice that we get 90, okay? So this project involves mostly working in the aggregators package. You're going to have to read some of this code that I've already written as part of this assignment, and you're going to be completing the code for aggregator processor. And to test out the code, you're going to right-click this aggregator app class and go to run as Java application to test out whether it's working. So similar to min, we have a mean, which is going to calculate the average. And I can state which column. So for example, this was the first column. If I change it to the third column here, and let's change this to mean. I'm going to change it MEAN, mean aggregator. And I'm going to also change that inside of the generics. And then just do the Control-Shift-O to bring in the mean aggregator import. So now this is going to, when I run this, it's going to calculate the average for all the data in the third column. And I can cross-verify that in Excel, the first, second, third column. If I change this instead of min, if I change this to the average function, this returns a 113.51004. So this is the value that I expect to be printed out to the screen when I right-click and go to run as a Java application, and notice that that's exactly, for the most part, that's the data that is in this Excel sheet, okay? So average is working. So take a look at the aggregator, the max aggregator, mean, min, to understand what's going on, and then complete the aggregator processor for this assignment. But the important thing to keep in mind is that I don't want you to change any of the code that you receive in this aggregator app. What you see here may be commented out when you receive this file. So your job is going to be to uncomment the code and make sure that it compiles first of all, and then when you run it, it should give you the expected results. So don't change anything in this aggregator app class. You're only going to be working inside of the aggregator processor to implement this run aggregator method so that this code behaves as expected. And you can do this without the use of generics, okay? But I don't want you to be left with that option, right? I want to force you to use generics. So the way I'm using it right now, the way it's shown on this line, that's how you're going to have to define that class to make this code work. All right, so I'm setting these constraints for you on purpose so you have an exact objective as to what the deliverable is going to be so that you get the opportunity to exercise those areas that you're learning. And another thing is you're going to be reading this table.csv file. I don't want you to rewrite the code for reading data. We've already done that in the file processors package right here, the stock file reader. Double click this method down here, this read file data already does what we want it to do. So you're going to be utilizing this method inside of this aggregator processor class to read the data and do what this run aggregator method is supposed to do on any given column, okay? So we've got some strict constraints that you have to abide by in the aggregator app class. Don't change any of this code. Right-click this class to run the Java application to test out whether your code is working. For the mean aggregator, you should be getting the value 113.5100. And if you were to change this to max aggregator, right, let me just change that in each one of these locations and do the Control-Shift-O to bring in the import. When you run this, you should be getting a 143.8099, okay, for the third column. And let me change this to the first column and leave the code as is. Let's hit play, and you should be getting a 144.289993, okay? So work on this assignment, take your time, struggle with it if you have to, and only then move on to my solution, which is going to be covered in the next lesson. So I'm going to wrap it up here. Thanks for watching. I'll see you in the solution.